my dear children, so I am back with the third and the final video of this video series on triangle and its properties, class 7 maths. And in this video we are going to learn about a very important theorem, which is the Pythagoras theorem. Yes, now this is like the backbone of mathematics, and we are going to learn about this theorem, how did it come into being, the proof of Pythagoras theorem, and obviously a lot of questions based on this theorem. So are we all set to go? Let's get started. So now we are going to learn about Pythagoras theorem. So Pythagoras was a very famous Greek philosopher and mathematician, and he gave a very interesting property on right-angled triangle. And you will see it for yourself that how this property helped to find solution to a lot of problems that involved a right-angled triangle. So what this theorem stated was basically something like this. So he said that if you have a right-angled triangle like this, now, even before we talk about this theorem, let us first understand the various terminologies related to a right-angled triangle. So whenever you have any right-angled triangle, let's call this as ABC. So this ABC is a right-angled triangle where you have one right angle, that is 90 degree. Now the side which is opposite to this right angle, that is this side AC, this is called the hypotenuse. Now the base, this one is the base, and this one is called the perpendicular. So perpendicular, hypotenuse and base, these are the three sides of the right angle triangle. Okay, now according to this theorem, it said that, let's say that you have a right angled triangle such that let's say the length of the hypotenuse is C, the length of the base is B, and the length of the perpendicular is A. And if we assume that on each of these sides, on perpendicular, base as well as hypotenuse, on each of them, if we assume that we draw a square, let's say we draw a square on the perpendicular, that means this square, each side of the square would be equal to A, right? Similarly, let's draw a square on the base. So that means each side of this square would be B. And in a similar way, we draw a square on this hypotenuse. So here each side would be C. So as per this theorem, that the area of this square, that is, what would be the area of this square? The area would be C square, because area of a square is side into side. So area of this would be C square, and area of this square would be B square, and area of this square would be A square. So according to Pythagoras theorem, C square is equal to A square plus B square. That is, the area of the square which is drawn on the hypotenuse is equal to the sum of the areas of the squares which are drawn on the perpendicular and the base sides respectively. So this was the Pythagoras theorem. Now you might be wondering that how come he was able to find out such a complicated relation, because we started with a right angle triangle and then we had drawn squares on each side of the triangle, and then we have kind of derived this relation. Well, this is not how it was derived. Now, this theorem can be proved in a number of ways. So here we will look at a proof of the Pythagoras theorem by rearrangement. So we will see that how we can rearrange triangles and we can prove that C square is equal to A square plus B square. That is, hypotenuse square is equal to square of the base plus square of the perpendicular. So as per Pythagoras theorem, in a right angle triangle, square of the hypotenuse is equal to sum of the squares on the legs. Legs would mean the base and the perpendicular. Now, even before we start proving Pythagoras theorem, let us try to understand why Pythagoras theorem. Why do we need this theorem? Where will this theorem help us? Now, let us think of an example. Let's say that you know how far your school is from your home. So this is your school and this is definitely your home. So you know the distance of your school from your home. Perfect. And you also know how far is the park from your school. So you know the distance of the school from your home. You also know the distance of the park from your school. Now let's say that on a holiday when you are at home, you feel like going to the park, but you do not know the direct route of the park from your home because you always went to the park through your school. So what would you do? So this is something which you normally followed. You went to the school and from school you went to the park. Now on a Sunday when you feel like going to the park, do you think that you would like to follow this route wherein you first go to school and then you go to the park? Not really, right? You might feel like preferring a route where you can directly go from your home to the park. So in that case, you might even follow this path. So in that case, now when you look at this entire route thing, you see that it is a right angled triangle. And in this right angled triangle, which is the hypotenuse, this is the hypotenuse. Let's call it H. And these are the other two legs. Let us call this as base. Let us call this as P, that is perpendicular. Now with the help of this relation, hypotenuse square is equal to sum of the squares of the other two legs. Using these two relations, we can very easily find out this distance H. So that's how Pythagoras theorem can help us in real life problems. Let's say that you want to climb on ladder to reach out to the top shelves in your house. Maybe you want to find out a book from the top shelf where you cannot reach normally, so you need a ladder. Now, you are in a doubt that how exactly should you orient the ladder so that you can reach that specific height where you want to. Because it might be possible that the ladder is too long. So you actually need to orient it in a way that you are able to reach that particular height. So how would you decide that? So let's say this is the wall, or these are the shelves, and this is your ladder. So the orientation of the ladder would be decided by the distance of the foot of the ladder from the foot of the wall. So this distance is nothing but your base. The length of the ladder is nothing but H, and this height, the desired height where you want to reach, that height is, let's say, P. So again, using the relation H square is equal to P square plus B square, you can actually decide where exactly you should place the ladder. So in this way, the Pythagoras theorem can actually help in a lot of real life problems, and that is the significance of Pythagoras theorem. In fact, based on Pythagoras theorem, a lot of other mathematical relations had been proved later. So now let us try to prove the Pythagoras theorem by rearrangement. So the first thing that you need to do is you make 8 right angle triangles of sides A, B, C respectively. So here what do you see on the screen? There are 8 right angle triangles. Each have 3 sides whose dimensions are A, B and C respectively. So they are all identical triangles. Now what you need to do is you take a square sheet on a cardboard. So you fix a square sheet on a cardboard, and then what you do is you start picking up one of these triangles and then start putting the triangles on this square sheet in this way. Let's say you picked up the first triangle and you placed it on the square sheet. Second one, again you placed it, third one and fourth one. So in this way you have placed 4 triangles in this square sheet. What do you do with the remaining 4? So you do a similar thing with the remaining 4 on a different sheet. So you take another square sheet exactly identical to the first one, and now you again start placing these remaining 4 triangles, but now you will place it in a different pattern. So somewhat like this. You place the first one, second one, third one and fourth one. So this is how you placed them. So now you have placed all your triangles over 2 sheets of cardboard. Now please make sure that these 2 sheets which you have taken, they are in the shape of square, and both of them are of equal dimension. That means area of this square sheet is equal to the area of this square sheet. And also make sure that all the triangles that you had created, all the 8 triangles, they are also of equal area. So all of them should have the same dimensions ABC, right? So now what we have to understand here is, what have we actually done? So here we had one square sheet, right, in which we have placed 4 triangles. What have we done here in the second scenario? So this is the first scenario, this is our second scenario. So in the second sheet, what we have done is, again, the same size square sheet on which we have placed 4 triangles. So basically that would mean that this blue area, that is the remaining area on the first sheet, would be equal to the blue area in the second sheet. That's because both the sheets were of equal area. The square sheets are of equal area. Both of them have been occupied by 4 triangles each. So this here also 4 triangles have occupied some area. Here also 4 triangles have occupied some area. So the remaining area here is this blue area. The remaining here is the blue area. So the blue area here should be equal to the blue area here. That is very much logically true. I hope you agree with me till here. Okay. Now we have to see that what is this blue area here and what is this blue area here. So for that, what we do, we just name the sides, because that's what we had drawn it like this. So every triangle has ABC, ABC and so on. So what do we see? Now if I ask you, what is this blue area? Can you find out this blue area? So what would be the area of this blue region? This is basically a square whose all sides are equal. Each side is equal to C. So the area would be side into side, that is C into C, which is C square. What would be this blue area? So when you look at this particular blue area, here also all sides are equal. B, B, B and B. This is also going to be B because you see these lines are parallel. So the area of this blue region again would be B into B, that is B square. What about the area of this particular region? This is again going to be side into side, which is A into A, that is A square. So that basically means that the area of the blue region here would be equal to C square. And the area of the blue region here would be A square plus B square, because this area plus this area. And as per our logic, this blue area should be equal to this blue area. That means C square should be equal to A square plus B square. And this is exactly what Pythagoras theorem is. Right? So basically we have proved that C square, which is nothing but the hypotenuse square, is equal to the square of the other 2 legs. So that's the Pythagoras theorem. So you see, this is a very simple rearrangement experiment which I believe you can do it on your own. So all you need is few sheets of paper, draw identical 8 right angle triangles. Okay, and then you take 2 sheets of cardboard and start placing the triangles in this particular pattern, and you will prove it for yourself that C square is equal to A square plus B square. Now many times people find it very complicated. When you read it in a textbook or when you see it in some animation, it might appear to be, kind of very difficult and confusing, but actually it is not. It is pretty simple. All you need is 8 identical right angle triangle and 2 square sheets. That's it. So this is how we have proved the Pythagoras theorem. There is another interesting part of the Pythagoras theorem, and that is its converse. Now, when we say that if we have any right angle triangle, 8 square should be equal to P square plus B square. Now the question is, if the Pythagoras theorem holds true, let's say if we have a triangle like the one which we see on the screen. I do not know whether it is a right angle triangle or not. But let's say that if we know that for this particular triangle, the square of one of its sides is equal to the sum of the squares of the other 2 sides. That means we do not know if it is right angle triangle or not, but we somehow see that the Pythagoras theorem holds true for this triangle. Does that mean that this would be a right angle triangle? So just the vice versa of what we had learned in Pythagoras theorem. So if the Pythagoras property holds true, that means the triangle must be a right angled triangle. That means, let's say if you have this triangle, let's say this triangle is ABC. And let us say we do not know whether it is a right angle triangle or not, but we know that For this particular triangle, BC square is equal to AB square plus AC square. So this relation is true for this. If this relation is true for this triangle, that means triangle ABC is definitely a right angled triangle. So it must be a right angled triangle. So doesn't matter how the triangles are oriented. Now at many a times, you are very easily able to identify the presence of a right angle. So it doesn't matter how it is oriented. But the moment the Pythagoras property holds true, that would prove by itself that the triangle is a right angled triangle. So let us even take one example. Let's say that you have this triangle where the dimensions are given as 5 centimeter, 4 centimeter and 3 centimeter. Now you have to determine whether it is a right angle triangle or not. So what you do, you just see if 5 square is equal to 3 square plus 4 square. So 5 square is 25 and this is 9 plus 16, which is 25. Now since this holds true, that means this is a right angled triangle. So based on whatever we have learned in the Pythagoras theorem, let us quickly have a look at some of the questions. Question number 1. ABC is a triangle right angled at C. So let us draw a triangle ABC which is right angled at C. Right angled at C means the right angle is at the vertex C. So this is C, let us call this A, let us call this B. So this is ABC. AB is equal to 25 centimeters. So AB is 25 centimeters. AC is equal to 7 centimeter. Find BC. So we have to find out BC. So which is the hypotenuse? AB is the hypotenuse. So as per Pythagoras theorem, what do we know? We know hypotenuse square is equal to perpendicular square plus base square. So what is hypotenuse? Here hypotenuse is 25. So 25 square is equal to 7 square plus base square. Base is something that we need to find out. So 25 square would be 625. 7 into 7 would be 49 plus b square. Therefore, b square would be equal to 625 minus 49, which is equal to 576. Therefore, b will be equal to root over 576. So, root over 576 means you will have to find out such a value which when multiplied by itself gives 576. So, how do we find that? So, for that we do prime factorization of 576. So, how do we do prime factorization? We have learned this in class 6th, right? So, you divide it by the smallest possible prime number. So you get numbers like this and you continue the process. So this is what you get. So when you actually prime factorize 576, it comes out to be 2 into 2 into 2 into 2 into 2 into 2 into 3 into 3. So basically this can be rearranged and written somewhat like this. You have a total of 6 twos. So 3 2's together, again 3 2's together. You have 2 3's, so 1 3 and 1 3. So what you can do is, this can be written as 2 into 2 into 2 into 3. So you take 1 out of these and 1 out of this. So you get this multiplied by again the same thing, 2 into 2 into 2 into 3. So this is how we do prime factorization, right? So 2 2's are 4, 2's are 8. 3 is a 24. So 576 can be written as 24 into 24. Therefore, root over 576 is equal to 24 centimeter. Therefore, the value of BC would be 24 centimeters. Question number 2. A 15 meter long ladder reached a window 12 meters high from the ground on placing it against a wall at a distance A. So this is the ladder, 15 meters. Height 12 meters and the distance from the wall is A. Find the distance of the foot of the ladder from the wall. So basically we will have to find the value of A. So again we'll use Pythagoras theorem. So hypotenuse square. So here which is the hypotenuse? This ladder is the hypotenuse. Therefore 15 square is equal to 12 square plus A square. So 15 into 15 is 225 is equal to 12 into 12 is 144 plus a square. Or we can say that a square is equal to 225 minus 144. So this is 81. Therefore, a is equal to root over 81, which is equal to 9 centimeters. Therefore, the distance of the foot of the ladder from the wall is 9 centimeters. Question number 3. A tree is broken at a height of 5 meters from the ground and its top touches the ground at a distance of 12 meters from the base of the tree. So here you have to understand something. Let's say that you had a tree like this. And let's say that this is the ground. So this is how the tree was initially. Now what happened is you need to find the total height of the tree, original height of the tree. So this was the original height of the tree. Now what happened was, due to some reason, this tree is broken at a height of 5 meters from the ground. So let's say that at a height of 5 meters from the ground, this tree was broken like this. So the tree was broken and it fell to the ground. Now what happened? Now this says that it has broken at a distance of 5 meters. That means this height is actually 5 meters. So this height is 5 meters. And it also says that the top touches the ground at a distance of 12 meters from the base of the tree. This is the base of the tree and this is where the top touches the ground. So basically this distance is given as 12 meters. So we have to find out the original height of the tree. So the original height of the tree would be this height plus this height, right? So you actually need to find this x. So once you find x plus 5 would be the original height of the tree. So how do we find x? So to find x, we make use of Pythagoras theorem. X square is equal to 5 square plus 12 square. So 5 5s are 25, 12 into 12 is 144. This is equal to 169. So x is equal to root over 169 and root over 169 is nothing but 13 centimeters. So this is 13 centimeters. So original height would be what? This entire height, right? So before it was broken, that means when it was not broken, this part was also erect. So basically original height would be equal to 13 plus 5, that is equal to 18 meters. So these were all in meters. So this was also meter. So the original height of the tree would be 18 meters. Question number 4. Angles Q and R of a triangle PQR are 25 degree and 65 degree. Write which of the following is true. Now this is 25, this is 65. Can we find this angle? Yes, we can, because we know that sum of the three angles of a triangle is 180 degree. So angle P plus angle Q plus angle R is equal to 180 degree. So angle P plus 25 degree plus 65 degree is equal to 180 degree. So what is 65 plus 25? That is 90 degree. This is equal to 180 degree. Therefore angle P is equal to 180 minus 90, which is equal to 90 degree. So we find that this angle P is 90 degree, which tells us that triangle PQR is a right angled triangle. Now in a right angled triangle, as per Pythagoras theorem, hypotenuse square, which is the hypotenuse, the side opposite to the right angle. That means this is hypotenuse. So as per Pythagoras theorem, hypotenuse square, that is QR square, is equal to PQ square plus PR square. So QR square is equal to PQ square plus PR square. So this is true. Question number 5. The diagonals of a rhombus measure 16 centimeter and 30 centimeter. Find its perimeter. So what is a rhombus? So a rhombus is a quadrilateral, that is a polygon with 4 sides, such that all sides are equal, but all angles are not equal. So this is a rhombus where all sides are equal. Let us say let's say we name the rhombus as ABCD such that AD is equal to AB is equal to BC is equal to CD. All the sides are equal. Now in this question, the diagonals of the rhombus are given. So these are the two diagonals of the rhombus, and let's say that the diagonals bisect each other at point O. Now as per property of rhombus, now when we talk about a rhombus, there are a few important properties of rhombus. The first property is that all sides are equal. The second property is that diagonals bisect each other at 90 degrees. That means the diagonals are perpendicular to each other. This is 90 degree, this is 90 degree, this is 90 degree, this is 90 degree. So that is another thing. So that ways we see that each of these triangles is a right angled triangle. Whether you talk about triangle AOD or you talk about triangle COD. So each of these triangles is a right angled triangle. Now what is given in the question? So in the question, AC is given as, let's say, 30 centimeters and BD is given as 16 centimeters. So basically both the diagonals are given. We have to find out the perimeter, that means boundary. So perimeter would be like sum of all the four sides. So if we are able to find out one side, we will just multiply it by 4 to find the perimeter. Right? So how do we find one side? So in order to find one side, let us focus on one right angled triangle. Let us focus on this triangle. So in triangle AOD, as per Pythagoras theorem, what can we say? Hypotenuse square, which would be the hypotenuse. This is the 90 degree. So the side opposite to 90 degree is AD. So basically AD square will be equal to AO square plus DO square. Right? So what is AO? AO is nothing but half of the diagonal AC. So AO will be equal to half of AC. So half of AC would be 15 centimeter. Similarly, what would be DO? DO will be half of BD. That is equal to 16 by 2, which is equal to 8 centimeter. So AO can be written as 15 square. Similarly, DO can be written as 8. So this is 8 square. So 15 square would be 225. 8 square would be 64. So this would be 289. Therefore, the value of AD will be equal to root over 289, which is equal to 17 centimeters. Therefore, we found out one side of the rhombus, which is 17 centimeter. Now, what would be the perimeter? Perimeter is equal to sum of all the four sides. That is adding 17 for 4 times, which is nothing but 4 into side. That is equal to 4 into 17, which is equal to 68 centimeters. Therefore, perimeter of the rhombus would be 68 centimeters.
I hope you found the video useful, and if you really understood the concept well, do write in the comment section that concept hua crystal clear. And I will see you all very soon with a new topic and a new video. Till then, take care. Bye-bye.